Unit 11.4, Chapter 5.4 in your textbooks, Exponential Logarithmic Equations Continued. The objective is students will successfully solve simple and complicated, we're going to be doing the complicated ones today, exponential and logarithmic equations. Okay, we want to solve the following exponential equations. E to the 2x minus 5e to the x plus 6 equals 0. Now, this is actually a quadratic, but it's actually pretty hard for people to see, even math teachers. So we do a little trick. It's substitution trick. So we take and pull out the power of 2, so it's e to the x to the second. Okay, and then we have e to the x here and an e to the x there. We can replace e to the x with u. So our equation becomes, this becomes a u, so u squared minus 5, this becomes a u, 5u, plus 6. This is much easier to factor than our original equation because it's just hard to see it. So again, what factors multiply to give you positive 6 but add to give you negative 5? So that is going to be u minus 3 and u minus 2. You're going to put back in your e to the x once you have it factored. So now that we have two factors, we are going to set each factor equal to 0 so that we can solve. So e to the x minus 3 equals 0 and e to the x minus 2 equals 0. Solve each one, so move the 3 to the other side. Now we need to get rid of the power, and we're going to take the natural logarithm of both sides because that is the same base as our e to the x. So we get x equals natural log of 3. We're going to plug that into the calculator and round to 3 decimal places. So we get about 1.099. We're going to repeat the process for our other factors. So we're going to move 2 to the other side. We're going to take the natural log of both sides, and we get x equals the natural log of 2. Plug that in the calculator, round to 3 decimals, we get about 0.693. Now, this is really important on all of these problems. You have to check your answers. Okay? By the simple way of our solving, we can get extra answers, and you never know when they're going to pop up, so you have to check them all. So you can just use your calculator, and I did the first one. So e to the 2 times 1.099 minus 5e to the 1.099 plus 6. Make sure you close these brackets or these parentheses on your exponent power, or use your arrow keys to get out of the exponent depending on your operating system on your calculator. We get 0.001164 yada yada. Okay, that is close enough to 0 for us because again, we're checking in our original equation and it was equal to 0. Okay, so close enough to 0 that we're good. Then you're going to take your other one, plug that one in, and when you see e to the negative 4th, that is really scientific notation. So this is really 0.000294 blah blah blah. So this is even less than this one, which means it's even closer to 0. So both our answers are good. So our answers are x is approximately 0.693 and 1.099. Okay, next example. We have the natural log of x equals 8. So we are going to exponentiate with base e because e and ln have the same base. So we get x equals e to the 8th. We need to check our answer to make sure that we aren't getting anything extra. Okay. When you plug it in the calculator, you are okay checking that it works. And that one's not too difficult to plug in. That is why I didn't do that one for you. If you are struggling on that one, please ask in class and I will do it for you. Okay, next one. Okay, we have log base 4 of 3x minus 2 equals log base 4 of 5x plus 8. We are going to exponentiate with base 4 because that is the base on our logarithm. So our logs are going to cancel out and we are left with 3x minus 2 equals 5x plus 8. We're going to solve with basic algebra, move our x's to the same side, move our constants to the same side, divide, and we get x equals negative 5. Again, you have to check your answers. So plugging in, and we're plugging in and not using the calculator because we are doing base 4. Okay, so 3 times negative 5 is negative 15. 5 times negative 5 is negative 25. And then we are going to, just simplify. And now most of you are like, oh, yay, we got the left side to equal the right side. But are we allowed to do the logarithm of a negative number? Okay. The answer is no. So in this case, we actually have no solution. If this came down to positive 17 log base 4 of positive 17 equals log base 4 of positive 17, then we could have kept our answer. But because we have a negative in here, you can't do the logarithm of a negative number, no matter what the base is. So we have no solution on this one. Okay, and many kids are going to ask, but how do you plug that sort of stuff in the calculator? What do you see in the calculator? I will show you that on a future problem here. Okay, we want to solve the following logarithmic equation again. We need to get the logarithm by itself. So we're going to subtract 4 from both sides. Then we're going to divide by 4 on both sides. I'm sorry, we didn't divide. We moved the 4 into a power. Now we're going to exponentiate with base e because natural log and e have the same base. So we have x to the 4th equals e to the 2nd. We're going to do the 4th root, or we're going to take it to the 4th power, 1/4 power, which is a 4th root. So we end up with x equals e to the 1/2, which is approximately 1.649. We have to check that answer. So when we plug it in the calculator, okay, we get 6.0067, blah, blah, blah. And remember, we are plugging it back into our original equation and checking, does the right side equal the left side? Okay, and in this case, yes, it does. So our answer is 1.649. Again, we want to round all of these answers to 3 decimal places. Okay, another example. Log base 10 of 3x plus log base 10 of x minus 1 equals 4. We have to get the logarithm into a single logarithm. We cannot exponentiate when we have multiple logarithms on the same side. So I used our product rule that says when we have addition, we can turn it into multiplication inside of a single logarithm. And now we can exponentiate. We're going to exponentiate with base 10. So we get 3x squared minus 3x equals 10 to the 4th. That looks like a quadratic, which means everything needs to go to the same side. And we're going to expand that 10 to the 4th. So if you want, you can skip that one step and just write it all over on one side with the expansion of 10 to the 4th. And now since that we got 10,000, that's an awfully big number to factor. So I would suggest just using the quadratic formula. So we have negative b, so negative 3 plus or minus negative 3 squared minus 4 times a, which is 3, times c, which is negative 10,000, all over 2a. A is 3. Type those into the calculator and you get negative 57.237 and 58.237. Remember to check your answers. So we plug in our negative 57.237 and you can hit enter. And we get error, non-real answer. What that means, when you did the logarithm, you were doing the logarithm of a negative. So that's what your calculator says to you when you try to do that. Okay, so that means we are going to have to go back and cross off our negative 57.23. Now we're going to try our positive 58.23. We do get 3.999, 5 nines there, close enough to 4 that we would be happy with that. So 58.237 is an answer that we can keep. Your homework is chapter 5.4, page 424, 31 through 51 odd, 77 through 101 odd.